Welcome back to Explaining Everything, the channel where we uncover the fascinating science behind everyday mysteries. Today's question comes from one of our viewers, Kevin Sandoval. Thanks, Kevin. You asked, how do microwaves heat up our food? We all use microwaves, but have you ever stopped to wonder what's actually happening inside? How does cold lasagna turn hot in just a few minutes? And why does the plate sometimes stay cool? In today's episode, we're diving into the science and chemistry behind the microwave's magic. So, whether you're a curious foodie or just want to impress your friends with some kitchen science, stick around here on Explaining Everything. To understand how your microwave works, we first need to know what microwaves actually are. They're not just a kitchen appliance. They're a type of electromagnetic wave, like light or radio waves, but with a specific frequency. Your microwave oven generates waves with a frequency of 2.45 gigahertz. That's a very specific number chosen because it interacts perfectly with one key ingredient in most foods: water. Microwaves are invisible, but they pack enough energy to set certain molecules in motion. And when molecules move, they generate heat. Pretty cool, right? Let's dive deeper. So here's the fun part. Inside your microwave, there's a device called a magnetron. It takes electricity and converts it into microwaves. These waves bounce around inside the oven, reflecting off its metal walls until they hit your food. But why does food heat up? It's all about the water. Most foods contain water, and water molecules are polar. They have a slightly positive side and a slightly negative side, kind of like tiny magnets. When the microwaves hit the food, they create a rapidly changing electromagnetic field. This field causes the water molecules to twist and spin back and forth millions of times per second. That movement creates friction between molecules, which generates heat. And that's why your soup goes from fridge cold to piping hot in just a couple of minutes. Now, here's something you've probably noticed. Your food gets hot, but the plate or container sometimes doesn't. Why? It all depends on the material. Microwaves interact primarily with polar molecules, like water, fat, or sugar. Materials like glass, ceramic, or plastic don't absorb microwaves very well, which is why they often stay cooler. Metal, on the other hand, reflects microwaves, and that's why it's a big no-no to put foil or metal objects in your microwave. Not only will they not heat up, but they can also cause sparks and damage the appliance. Let's leave the metal experiments to the professionals. Time to clear up some misconceptions. First, microwaves don't make your food radioactive. They're non-ionizing waves, meaning they don't have enough energy to change the structure of your food's molecules. They just make those molecules vibrate. Nothing more. Second, have you heard the myth that microwaves cook food from the inside out? Not quite. Microwaves only penetrate about an inch or so into food. The rest of the heat is spread through conduction, the same way it happens in an oven. So, next time your lasagna has cold spots, it's not the microwave's fault. Give it a good stir before reheating. Ever noticed that warm glow inside your microwave when it's running? That's not the microwaves themselves. They're invisible to our eyes. The glow comes from a regular light bulb inside the appliance, so you can check on your food. However, if you've ever seen sparks or flashes of light, that's another story. It's called arcing and usually happens when metals or certain uneven materials reflect the microwaves. Another reason to keep foil out of the microwave. Want to see some microwave science in action? Here are a couple of safe experiments to try. First, the soap expansion. Place a bar of ivory soap on a plate and microwave it for about a minute. It'll expand into a foam-like cloud. The heat makes the air trapped inside the soap expand, and the results are pretty dramatic. Second, marshmallow madness. Put a marshmallow in the microwave for 10 to 20 seconds and watch it puff up like a balloon. Just don't let it melt completely. Cleanup can be messy. Remember, always be cautious with these experiments and avoid putting anything metallic in the microwave. It's hard to imagine life without the microwave. Before its invention, reheating food meant using a stove or oven, which could take ages. The microwave made cooking faster, more convenient, and even more energy efficient. Unlike a conventional oven, microwaves focus their energy directly on the food, so you're not wasting heat on the surrounding air or appliance walls. That's a win for your time and your electricity bill. And there you have it, the chemistry and physics behind how microwaves heat our food. From spinning water molecules to arcing sparks, there's so much science happening every time you press a start. Thank you for watching. If you learned something new today, don't forget to like this video and subscribe for more fun, bite-sized science. If you have suggestions for our next video, feel free to share them in the comments below. We'll be sure to give you an acknowledgement for your contribution. Until next time, keep asking questions, stay curious, and enjoy your microwaved leftovers.